Today we're going to continue to look at section 2.5, which is transformations of functions. So once again, we're going to be looking at all the different types of transformations. So vertical and horizontal shifts, reflections, stretches and shrinks. So we're going to put a bunch of those together. All right, so notice that below we have the graph y equals f of x. We want to transform this into the function g of x, which equals -1/2 times f of x plus 2. So there's several different transformations that are happening. Because there's a negative, we know that there's going to be reflection. So this is going to be turned around. 1/2, that's telling us that we're going to deal, because it's outside of the function, it's going to be shrinking. And then since we're adding 2 outside of the function, that means it's going to be moving up 2. So since there's quite a few things going on here, I think that the easiest thing to do is, honestly, I'm going to just create a table based off of the ordered pairs for the f of x function, and then I'm going to manipulate the ordered pairs by just continuing on with this table, and then I can plot those new ordered pairs for my g of x. So we've got the ordered pair -4, 0, -2, 4, 0, 0, 2, -2, and 4, 0. Okay, so there's my original function. Now I want to start going ahead and transforming it. So I'm going to always deal with the multiplication aspect of it first. So I know that I want to multiply the f of x column by -1/2. So 0 times -1/2 is still 0. 4 times -1/2 is -2. 0 times -1/2 is 0. -2 times -1/2 is +1. 0 times -1/2 is 0. Okay, now I want to take that information and I want to add 2 onto it. So I'm going to, since the 2 is on the outside, it is getting added on to this f of x column that we just created. So 0 plus 2 is 2. -2 plus 2 is 0. 0 plus 2 is 2. 1 plus 2 is 3. 0 plus 2 is 2. All right, so now that I have that, I can plot my ordered pairs. So notice that nothing changed with the x's. So the -4 is still -4, but now we go to +2. And then -2 goes to 0. And then 0 goes to 2. Looks like 2 goes to 3. And 4 goes to 2. So these are the points that are going to be in my g of x function. So -4, 2, -2, 0, 0, 2. We've got 2, 3, and 4, 2. Okay, so notice that we've got the parabola shape here, and then we've got our V shape there. Okay, so notice that it's flipped upside down because of that negative. It's the reflection. Notice that everything has shrunk. The points are closer to each other, and that's because of the 1/2, and then it got shifted up too. So this was my new g of x function. All right, let's continue this thought process, but now let's look at just our basic parent function, f of x equals the absolute value of x. So I'm going to start there. If we're dealing with an absolute value, we know that we can substitute in negatives, positives, and 0. So I'm going to make a table going from -2 to +2. Absolute value means that everything comes out positive. So we should have a shape of a V. I'm going to plot this to get my first function on the graph. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. All right. So extending that out. This is my f of x function, so I labeled it. All right, so we have several different things happening. I see that there's a 2 outside, so that tells us that we are going to multiply by the f of x column, and I want to do that first. I always do multiplication to stretch or to shrink before I do any type of horizontal or vertical shifts. So I'm multiplying the second column by 2. So 2 times 2 is 4, 1 times 2 is 2, 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4. All right, so notice that inside of the absolute value, I see x plus 1. Remember, I'm thinking the opposite, so I really want to take that first column and subtract 1. So negative 2 minus 1 is negative 3. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. 1 minus 1 is 0. 2 minus 1 is 1. And then finally, I have a negative outside, or negative 1 outside. So that means that my new column, which is this 2 times f of x, I am going to be subtracting 1 from them. So I'm taking 4 minus 1, so 3. 2 minus 1 is 1. 0 minus 1 is negative 1. 2 minus 1 is 1. 4 minus 1 is 3. So here are my ordered pairs. Negative 3, 3, negative 2, 1, negative 1, negative 1, 0, 1, and 1, 3. So I'm going to plot those points. We got negative 3, 3, negative 2, 1, negative 1, 1. Or sorry, I'm doing this incorrectly. Yikes, I just don't know how to plot points. Okay, so wait, negative 3, 3. Negative 2, 1 is down here. Negative 1 is there. We've got 0, 1, and we've got 1, 3. All right, so notice that. Oops, dropped better than I did. So you should be able to use a straight edge, so some kind of ruler. I can't do that on my tablet here. And then I'm labeling it. This is my g of x function. So notice that it is definitely going to be stretched here. It's getting bigger faster. Okay, we are shifting 1 to the left and 1 down. All right. Let's take a look at another example. We're going to graph our parent function of f of x equals x squared. So I'll start there. Remember, squared term means we're thinking parabola. I can square negatives. I can square 0. I can square positives. So that turns into these numbers. And I should have a shape of a U. So negative 2, 4. Negative 1, 1, 0, 0, 1, 1, 2, 4. So here is my parabola. Arrows on either side, labeling it f of x. All right, so if we take a look at the g of x function that we want to be creating, notice how there's a negative outside, so that means we're dealing with a reflection, and that's going to be affecting the f of x column because it is outside. So I'm going to take care of that first. So it's going to change all of the f of x to the opposite. All right, and then it looks like we have a horizontal and a vertical shift. So it looks like because I have x plus 3 in parentheses, my x column, I'm doing the opposite. I'm going to subtract 3. So negative 2 minus 3 is negative 5. Then we'll have negative 4, negative 3. Then we'll have negative 2. Then we'll have negative 1. So those are all the x values for my new ordered pairs. Now I want to take that new negative f of x column, and it looks like we have to add 4 onto it. Negative 4 and 4 is 0. Then we'll have 3. We'll have 4, 3, and back to 0. So it looks like the ordered pairs that I want: negative 5, 0, negative 4, 3, negative 3, 4, negative 2, 3, and negative 1, 0. Should look like a U. It should be upside down because we have that reflection. So negative 5, 0. We've got negative 4, 3. Negative 3, 4. We got negative 2, 3. And negative 1, 0. So here's my parabola. And it's my g of x function. So there's my two graphs. So pause the video, graph the parent function f of x equals the square root of x, and then create the new g of x function as well. All right, so remember square roots, we can only start with 0 underneath that parent function, and we can go from perfect square numbers up. So that's why we're heading towards the right. And then we had not only a reflection, so that's why my graph is upside down, but we had that 2 out in front, so it's a stretch. And then we had both a horizontal and a vertical shift. So once again, that's us using all the different shifts, the reflections, the stretching and the shrinking in order to form our new functions based off of